Morning, guys, and welcome to week 3 of the class, week 3 of chemical calculations. Today, we are going to be talking about a big concept and one that a lot of students sometimes get confused with, and that's that nice big long word on the screen there, stoichiometry. So before we get too far into stoichiometry or what it is, I actually want to take a break and I want to talk about my absolute favorite kind of chemistry, and that is the chemistry of cooking. This is an actual course. I'm taking a course in it right now. So we are going to talk about the chemistry, because believe it or not, this is chemistry of baking chocolate chip cookies. These are my beautiful protein chocolate chip cookies. All right, so here's the deal. I chose that I wanted to make myself some amazing chocolate chip cookies for breakfast and put some protein in it. I figured it's probably a bad idea though if I have a couple dozen cookies sitting around, and that's what the recipe actually made, was a couple dozen cookies. So what I did was some crafty math, and I figured out exactly how many ingredients I needed to make only 4 cookies, because that seemed like a reasonable amount to me. Sometimes you might go the other way and you might say, listen, I have a fridge full of eggs. I have a dozen eggs. How many cookies can I make with this dozen eggs? That type of math or that type of chemistry is actually exactly what stoichiometry is. So stoichiometry is going to be us figuring out how much of something we can make, or it's going to be figuring out how much of something we need to make a certain amount. That's all it is. It's going to be a couple steps, so it can seem overwhelming at times, but overall, the math itself is actually only multiplying or dividing. So as long as you follow these steps, you're going to be fine. So let's take a look a little bit more detail about stoichiometry. So I just mentioned this before. This is going to be really important in chemistry. So whether or not you're cooking or whether or not you're actually a chemist, you're trying to make a product, all stoichiometry is knowing the amount of ingredients that you might need or knowing how much of a product you might actually create. So it's really kind of a long, confusing word for a pretty easy concept, one that you've probably been doing for a while. Okay, so what's going to be important is in stoichiometry, we need to make sure that we have a balanced chemical equation, and that balanced chemical equation is going to allow you to figure out exactly how much of something that you might need. We're also going to be using the mole concept, that idea of the mole ratio that you learned next week. So we're going to use moles and the mole ratio and balanced chemical reactions to actually predict how much of a product we are going to be making. So just a couple definitions before we get to our first example here. And the definition that we want to start with actually what is stoichiometry. So it's the study of, I'm going to highlight this word here, quantitative. Remember, quantitative just means numbers. So it's a study of quantitative relationships among reactants used and the amount of products formed. So all that stoichiometry is studying how much of something you're putting in to get out, or how much is something you need to put in to a reaction and how much that's going to form. So we're just going to be looking at numbers and ratios this entire time. The steps in a stoichiometric calculation, we're always going to be following the same steps. And I'm actually going to give you an organizer that's going to help you in a little bit. So the organizer you can see in the PDF printout, there's actually really only 3.5 consistent steps to stoichiometry. The reason I call it a half a step is because before you even start, before you even get to your first step, you need to make sure you're doing a couple things. You need to make sure that you are reading the question carefully. What you're going to notice in our first example is that in stoichiometry, it's kind of like a word problem. I know as soon as I say that, some of you get a little bit nervous because we don't always love word problems in math, but I'm going to show you how to actually go through, read the question, pick out important information. So even that way, if you don't really understand what the question is asking you, you can actually figure out, just using the numbers, where you're trying to get to. The other thing that you want to do is you want to make sure that you are able to list your given values. So you need to make sure once you've read the question, you list all the information that you've been given. Remember, sometimes that's information that you've actually been given in terms of a number, or sometimes you might need to use a periodic table and that molar mass. So they might be giving you clues of information that you might need to look for and find yourself. The other thing that you need to make sure in this step that you're doing is you need to make sure you're writing a balanced chemical equation. Balancing, if you don't balance, you're going to have a bad time. How I always liken this is we're going to go back to cookies for a second. If you were explaining to someone exactly how to bake cookies and you were trying to say, all right, you need eggs, you need sugar, you need flour, you need chocolate chips. In my case, you need protein powder. That's actually not enough information, right? A recipe has two components. A recipe lists the ingredients, but a recipe also lists how much of the ingredients you need. That's what balancing a chemical reaction does. It's telling me that you need 2 eggs and a half a cup of flour to go through and to bake these cookies. So you need to make sure that you balance before you start your chemical reaction, before you start stoichiometry. Otherwise, you're not going to know exactly how much you need. Once you've done these things, we can go ahead and proceed to step 1. Step 1 can be summarized like this: mass to moles. You are going to always be given your information in a mass form, and you are always going to have to convert to a mole form. So that's why we spent so long practicing this last week and the week before. You have to be able to go to mass to moles easily. How do you do this? By using molar mass. So if you're not comfortable using molar mass yet, you might want to pause the video here, go back to last week's work, and practice again how to figure out a molar mass using a periodic table. So step 1 is mass to moles. Step 2 is going to be mole to mole. We can also call that mole ratio. So I got some really great questions last week saying, hey, I understand how to do mole ratio, but when do I actually use it? You weren't really using mole ratio last week. This week you are going to be using mole ratio. So it's the idea that I need 2 eggs to make a dozen cookies. So that ratio is going to be really important. Once you've done your mole ratio, then you're going to go from moles back to mass. Again, you know how to do that, and that's using molar mass. So essentially, we're always going to be giving you the mass of a reactant, and we're going to be asking how much of a product that's going to make. So you have to go from mass to moles of your reactant. You have to compare the molar ratio of reactant to product, and then you have to go back and tell me how many grams or the mass of the product you're going to form. So those are always going to be your 3 steps. And when we start, we're always going to make sure that we balance our chemical reaction and that we're listing the values given. Okay, so that's it. I'm going to walk through 2 examples with you of how to do these. I would suggest that you follow me for the first example all the way through. And then when you get to the second example, go ahead, pause the video, and see if you can actually try it yourself. So since we're going to be getting to an example, I'm going to go ahead, I'm going to close this screen down so that way I can actually write on my computer. And let's take a look at our first example. So our first example that we're going to be looking at, let's get my computer closer to me here. There we go. Our first example that we are going to be looking at is going to be propane. So here they've given you the chemical formula for propane. It's asking for the mass of oxygen that is needed to burn 15 grams of propane. So that's the first number that came up. We can see our mass of propane, and the question is asking us about the mass of oxygen. It's also giving you a reminder about how to write the chemical reaction. So it's reminding you of the 2 products in our chemical reaction. So this is going to be a combustion reaction. So we're going to go ahead and we're going to see carbon dioxide gas is going to be produced. And we're also going to see water vapor is going to be produced. So that's actually back from unit 1. So what you'd want to do at this point is you want to go ahead and you want to write out your balanced chemical reaction. So I'm going to show you just the basics down here before we get to our organizer of how to organize this. So we know this is a combustion reaction. We know that in combustion reactions, back to unit 2, one of our reactants is always going to be oxygen. The question has also reminded us that our 2 products are going to be carbon dioxide and our other product is going to be water. Our first reactant was given to us in the question. Our first reactant is propane. So they actually gave you the chemical formula, and that's going to be C3H eighth. So this is actually a really great question because it's kind of like a unit 3 and also a unit 2 question as well too. So before we can start the question, we want to go ahead and we want to make sure that we've balanced this chemical reaction. So again, why don't you pause the video and why don't you practice balancing? So if I was going to balance this chemical reaction, I'm first of all going to notice that I have 3 carbons on the left-hand side. So I'm going to go ahead and I'm going to put a 3 in front of this C here. That's going to give me the correct number of carbons. I'm also going to notice that I have 8 oxygens on the left-hand side. So I'm going to go ahead and I'm going to put a 4 in front of this H2O to give me 8 oxygens. Now my number of carbons is even. Now my number of hydrogens is even, so all I need to do is make my number of oxygens even. Well, if I look at my reactant side, I notice that here I have 6 oxygens, and here I have 4 oxygens. That's 10 oxygens total, so all I want to do is I want to go ahead and put a 5 here, and that's going to give me 10 oxygens on my left-hand side. We're actually going to start using what I call this reactant organizer. So this reactant organizer is going to allow us to actually record our information as we go. So we've got in words the chemical reaction at the top. We've actually taken that and we've gone ahead and we've actually turned it into a chemical formula. We know what the chemical formula for propane was. They gave us to that in the question. And then we've actually taken that one step further and we've balanced this. Our next bit of information is we want to go through and read the question and figure out what information was given to us. We were given one number, and that one number was the mass of propane. So I'm going to go ahead and I'm going to write that right underneath propane here. So my given mass was 15 grams. That's the only thing I was given in this question. The other important part of stoichiometry that you need to figure out is what it's actually asking you about. So let's go back to the question and see what we're actually being asked. If we read this question, propane is a gas used in barbecues. Calculate the mass of oxygen that is needed to burn. So the question is actually asking us about the mass of oxygen. So what I'm going to do is I'm going to go back to this chart and I'm going to write just a question mark underneath my oxygen. What that's telling me is that's what I'm looking for. This entire question, I'm given the mass of propane and I'm looking for the mass of oxygen that I need to make this reaction go. Here's the thing with stoichiometry is that I only am going to concentrate on what I was given and what I'm looking for. So I can actually go ahead and once I have my reaction balanced, I can essentially ignore carbon dioxide and water in this part. So I can put a big X through this kind of organizer here because I actually don't care about carbon dioxide. I don't care about water. All I care is about my ratio between propane and between oxygen. So my next step is I need to get to number of moles, right? That's step 1, go from mass to moles. In order to get to number of moles, I'm going to need to figure out both my molar mass of propane and while I'm here, I might as well figure out my molar mass of oxygen. So I'm going to do that on this screen. In order to figure out my molar mass of propane, I'm going to need to take my molar mass of carbon and multiply that by 3. Why am I multiplying that by 3? Because I have 3 carbons. I also need to take my molar mass of hydrogen and I'm going to multiply that by 8. Why am I multiplying by 8? Because I have 8 hydrogens in propane. So if I go through and I take a look at what those numbers are, I'm going to use my periodic table and it's going to tell me the molar mass of carbon is 12.011. And my molar mass of hydrogen is 1.008. If I go ahead and if I plug that into my calculator, I'm going to find that overall my molar mass of propane, let's try that again. I'm going to find overall my molar mass of propane is 44.097 grams per mole. All right, while I'm here, I might as well find my molar mass of oxygen because I'm going to need it at the end. So while I've got my periodic table in front of me, I'm going to calculate that as well too. And for my molar mass of oxygen, I'm going to take my molar mass of oxygen and I'm going to multiply it I'm going to multiply it by 2 because I have 2 oxygens in this case. Well, each oxygen, if I take a look at the periodic table, is 15 points, so close. Let's try one more time here. Hopefully this isn't so glitchy. 15.999. So if I go ahead and I plug that into my calculator, I'm going to find that overall I'm going to have 31. Ooh. These videos are so long because it's just me erasing the same pen stroke over and over and over again. 31.998 grams per mole. All right, now we have mass, now we have molar mass, so we can go ahead and we're ready to figure out number of moles. I'm going to remind you just below here what our calculation was for number of moles. So to figure out number of moles, you practiced this last week. To figure out number of moles, I'm going to take my mass and I'm going to divide it by my molar mass. So I have been given my mass of propane. I figured out my molar mass of propane, so I can go ahead and I can plug that into my formula. So I'm going to take my mass, which is 15 grams, and I'm going to divide by my molar mass, which is 44.097. Now, nice thing about including units is I can go through and I can see to make sure that I'm doing this correctly. So my units for molar mass is grams per mole. Well, since I have grams in the top and since I have grams in the bottom, these grams are going to go ahead and they're going to cancel out. And I'm going to find overall, if I plug that into my calculator, I'm going to get a grand total of 0.340 moles. So I now know my moles of propane. That's my first step. I went from mass to moles, and my moles of propane is 0.340 moles. All right, so we are going to go ahead to our next step. I'm going to scroll down here. This is all just a transcript of what I've written out for you, or typed out for you, so that way you can see. And our next step, to remind you, is going to be going from moles to moles. So in order to go from moles to moles, we're going to be using that mole ratio. So I've gone ahead and I've typed out here so you can at least see our mole ratio. So our starting product is propane, right? That's what we actually started with, is propane. And we just calculated how many moles of propane we have. And where we're trying to end up is the number of moles of oxygen. So I actually know my number of moles of propane. I went ahead and I already calculated that. So my number of moles of propane is going to be 0.340 moles of propane. That's C3H8. And I'm looking for my number of moles of oxygen. I don't know how many moles that is yet. So I'm going to call that X moles of O2. This is where your balanced chemical reaction comes into play. So on the other side, I'm going to use the coefficients, or the big numbers that are in front of propane and that are in front of oxygen, to help me with the other part of this formula here. So if I take a look at propane in the balanced chemical reaction, it has a 1 in front of it. So I'm going to write a 1 here for propane. And if I take a look at the big number in front of oxygen, it has a 5 in front of it. So I'm going to go ahead and write a 5 here for oxygen. Notice that I kept propane on the top, and notice that I kept oxygen on the bottom. My next step is I'm going to go through and I'm going to cross multiply. So cross multiplying means multiplying whatever is across from that variable. So I'm going to start with my X. I have X moles of O2. And I'm going to multiply it by what's across from it. And what's across from it is 1. 1 mole of C3H8. That's going to be equal to, well, I have 0.340 moles of C3H8. And I'm going to multiply that by 5 moles of O2. Now my next step is I want to go ahead and I want to get this oxygen by itself here. So to get this oxygen by itself here, I need to get rid of that one propane. To get rid of that one propane, I'm going to move it to the other side. I'm going to divide. So I'm going to have XO2 is going to be equal to, the top part of this is going to stay the exact same. So we're not touching that part yet. But the bottom part of this, we have to get rid of that one propane on the left. So we're going to divide by this propane over here. That's going to allow us to get X by itself. Now, if we've done this correctly, this is going to make sure that we cancel out. So we're going to have propane is being divided by propane. So that's going to go ahead and cancel out. So our number of moles of oxygen, so XO2, is going to be equal to 0.34 times 5. If I go ahead and I plug that in my calculator, I'm going to get 1.700 moles of oxygen. So that was step 2. I've now done my molar ratio. So my molar ratio can go ahead and be recorded into my chart. So let's update our chart here. That's just everything typed out, so you can go ahead and check that if you can't read my writing. So this was where we started. This was the information that we were given. This here was step 1. So we figured out the number of moles of propane. And this here is just us telling us the number of moles of oxygen. So we went from mass to moles. We did our molar ratio. So now we're on to our last step. And our last step is going to be going from moles to mass. We need to figure out now how many oxygen grams we have, or our mass of oxygen. So we're going to calculate MO2. And our formula that we're going to use is going to be mass is equal to number of moles times molar mass. Well, let's see if we have all the information that we need. Using molar ratio, we did go ahead and calculate the number of moles of oxygen. And at the very beginning, we calculated the molar mass of oxygen. So our last step is as easy as taking those two numbers and substituting them into that equation there. So all I'm going to do is I'm going to take my number of moles, which I just calculated using my molar ratio. That was 1.7 moles of O2. And I'm going to go ahead and I'm going to multiply that by my molar mass of oxygen. Remember, my molar mass of oxygen I calculated to be 31.998, and that was in grams per mole. Now I can see how my units are also going to cancel out. So this mole is going to cancel out, and this mole is going to cancel out. And if I go ahead and I plug that into my calculator, I'm going to find that overall, I'm going to get, actually, let's go over here so you can read this a little bit better. It's going to feel a little bit more grand over here. I'm going to get a total of 54.422 grams. So therefore, I would produce 54.422 grams of O2. So that's it. We've gone through and we've said that we have we can round that to 54, right? We have 54 grams of oxygen. So let's go through and let's summarize using this nice little chart here, everything that we just did. So a great summary of stoichiometry can be shown here, and these are the steps that we took. Before we actually started, we went through and balanced our chemical reactions, so we can see that we put our coefficients there. Our step number 1 is we went from mass to moles. Our step number 2 is we used our molar ratio, and our step number 3 is we converted from moles to mass. That's it. That is stoichiometry. That's actually one of the hardest stoichiometry questions that I can ask you. So I'm going to go ahead and I'm going to show you example 2. And example 2 is asking about the mass of oxygen that is produced with the decomposition of 12 grams of water into its elements. So this is asking about the mass of oxygen. So that's what it needs to, that's where we're going towards, is the mass of oxygen. How much of that is produced from the decomposition of 12 grams of water into its elements. So I'm going to say, go ahead, pause the video, try this question for yourself. So you're going to start by writing a balanced chemical equation. Then you're going to go from mass to moles. Then you're going to do molar ratio and then moles to mass. Go ahead, pause it, and come back to the video. Remember, if you get stuck, you can watch just that section, pause it again, and try from there. All right, so let's take this kind of one slide at a time. So the first thing that we need to do is we need to write our balanced chemical equation. So we were told in the question that water is decomposing into its individual elements. Well, we know water is made up of two things. Water is made up of hydrogen and water is made up of oxygen. So if I was going to go through, I'm going to go right on the white. I think you can see it a little bit better. If I was going to say my chemical formula for water, it'd be H2O. And that's being broken into its two elements, H2 and O2. Why did I write H2 and O2 and not just hydrogen and oxygen? Because remember, both hydrogen and oxygen are Hofbrinkels. They're considered to be diatomic, so we need to put that 2 there as well. All right, next thing we want to do is we want to make sure that this is balanced. We can see that it's not. We can see that on the right-hand side, I have an extra oxygen. So in order to balance that, I want to put a 2 in front of here. Now I have 2 oxygens on the left and 2 oxygens on the right. Now my hydrogens are not balanced. I have 4 oxygens on the left, so I'm going to put a 2 here. That's going to make sure that my hydrogens are balanced. So I now have my balanced chemical reaction for water is 2H2O, 2H2 plus O2. Next thing I want to do is I want to read my question and figure out what I've been given. In my question, I was told that I have 12 grams of water. In my question, I was also told that I'm looking for the amount of oxygen that will be released. So I'm looking for oxygen. What that means is now that I have my balanced chemical reaction, I only care about water and I only care about oxygen. So I can actually go ahead and essentially ignore hydrogen in this case. We don't have to do anything for hydrogen. We just need to look at oxygen and water. So I know I'm going to have to convert to the number of moles. So in this case, since I have to convert to the number of moles, I'm going to find my molar mass for oxygen and I'm going to find my molar mass for water. So my molar mass for oxygen is going to be my molar mass of hydrogen, and I have 2 hydrogens, plus my molar mass of oxygen, I only have 1 oxygen. If I look at the periodic table, my molar mass for hydrogen is 1.008. And if I look at the periodic table, my molar mass for oxygen is 15.999. If I go ahead and plug that into my calculator, I'm going to find that overall, my molar mass for water is going to be 18.015 grams per mole. I'm going to do the same thing for oxygen in this case. So I need to know the molar mass of oxygen, and I'm going to multiply this by 2 because in O2 I have 2 oxygens. If I look at the periodic table, I already checked for water, and my molar mass for oxygen is 15.999. So I'm going to go ahead and plug this into my calculator, and I'm going to find that I get 31.998 grams per mole for oxygen. Now I have my mass, now I have my molar mass, so I'm ready to go ahead and proceed to my next step, and that's going to be finding my number of moles of water. I'm just going to remind you that the formula for number of moles is equal to mass divided by molar mass. So I'm going to take my mass of water that I was given, that's 12 grams, and I'm going to divide by my molar mass of water that I just calculated, 18.015. And that's in grams per mole. I'm going to go ahead and cancel out my units. So my grams are going to cancel, and that mole is actually going to flip to the numerator there. And if I take 12 and I divide it by 18.015, I'm going to find that I get a grand total of 0.666 moles. All right, so my first step was to go from mass to moles. Now I'm at the step for my molar ratio. So I'm going to do my molar ratio, and my molar ratio is going to be between water and oxygen because that's what the question is asking us, is water and oxygen. So I'm going to set up my molar ratio. Look at how much work we did, right? That was all just stuff that we just did on that one little slide. This is everything expanded so you can see it. So I'm going to set up my molar ratio like this. I'm comparing water to oxygen. Now, I do know how many moles of water I have, so I'm going to go ahead, I'm going to plug that in, and that was 0.666 moles, and I'm just going to call that H2O. I'm going to shorten that just to make sure that we have enough room to write this all. What I don't know is my moles of oxygen. That's what I'm looking for. So I'm going to call that X. Now I'm going to take a look at my balanced chemical equation, and I'm going to find that I have a 2 in front of water. So I'm going to go ahead and I'm going to write a 2 there. And I'm going to find that I have a 1 in front of oxygen. So I'm going to go ahead and I'm going to write a 1 there. Our next step is that cross multiplication step. So I'm going to go ahead and I'm going to cross multiply, which means just to multiply by what's across. So that's going to give me XO2, and what's across from it is 2H2O. That's going to give me 0.666 H2O, and what's across from it? 1O2. My next step is I want to get this X by itself. I'm going to underline that. So to get that X by itself, we need to get rid of that 2. So to get rid of that 2, we need to divide. So we're going to have our XO2. My top part is going to stay the same. But now on my bottom, I'm dividing by that 2H2O. Again, if we've done this correctly, my units are going to go ahead and cancel out. So this H2O is going to cancel out. This H2O is going to be canceling out, and I'm going to be left with O2, which is what we want. That's good, right? Now I'm going to take 0.666 and I'm going to divide by 2, and I'm going to find that's going to give me 0.333. So overall, I'm going to find that using this molar ratio, I'm producing 0.333 moles of O2. So first step, we went from mass to moles. Second step, we did our molar ratio. That's it typed out right there for you. And our last step is we are on to that moles to mass step. So our last step is to calculate the mass of oxygen being produced. And our formula for that is going to be mass is equal to number of moles times molar mass. We have both of these values. We just calculated the number of moles. So my number of moles was 0.333 moles. My molar mass of oxygen, I calculated that my very first step. So my molar mass of oxygen was 31.998 grams per mole. Again, if we're doing this correctly, our units are going to cancel out. So this mole is going to cancel out. This mole is going to cancel out. And I'm going to find that I have, so close, keeping in suspense here. I'm going to find if I plug that into my calculator, I'm going to end up with 10.66 grams. I'm going to go ahead and I'm going to round this. I was actually only given 12 grams in the question. So since I was only given 12 grams in the question, I want to round this to an even number. So 10.66 is going to round to 11. So overall, I'm finding that 11 grams of oxygen is going to be produced when 12 grams of water decomposes. All right, that's it. So our overall question is here. We did amazing. That's stoichiometry. So you have some practice questions that I want you to try. So go ahead and try those practice questions. And then if you feel ready to move on, you can move on to our next and last lesson of the week, and that's going to be limiting reagent. Have a great day, guys. Go ahead, maybe bake yourself some cookies as well, too, and we'll see you next time. Bye.